And now can you plug in x equals 0? Yes, you can. And you get, if this is 0, the square root of 4 is 2 plus 2. The limit does exist, and it is equal to 1/4. Okay? Now, let's check out this 37 and 38. End behavior. When you're talking about end behavior, you want to know when x gets really, really big or really, really small. So what happens in the numerator and what happens in the denominator? When you do these end behavior problems, when x gets really, really big or really, really small, what do we do with the numerator? What do we do with the denominator? How do we start solving these end behavior problems? Yeah, the highest powers take over. So what's the highest power in the numerator? Well, it's just that x thing. What's the highest power in the denominator? Well, it's kind of like this thing, this x squared thing is going to get a lot bigger than this 4 thing. You know what I'm saying? But it's still under the square root sign. You see that, Katie? So end behavior, this thing is going to be modeled the same as this. What is the square root of x squared? Close. This is one of the definitions of absolute value. Because you square a number and then you take the square root of it. You're going to return the positive of the original value. Does that make sense? Do you guys know what I'm saying? Okay, so what is the limit as x approaches infinity of this function? Without looking at a graph. What is the value then? 1, right? It is really, if you're thinking about the x, they're going to cancel out. This equals 1. What is the limit as x approaches negative infinity? Take a look at the graph. Graph the original function, see what happens. X over the square root of x squared plus 4. What is the answer to problem 38? Why is it negative 1?
Because the x on top still stays on top.
Does that make sense, you guys? This answer is true. I agree with that. In 38, it still breaks down to this, only when you want the limit as x approaches negative infinity of x over the square root of x squared, this is going to become a really, really big negative number. This is still going to be that same really, really big number, only it's going to return the positive. So the negative divided by a positive is a negative. Does that make sense? There was a problem on the 2008 test non-calculated. And here it is actually right here. That they actually removed from the test. It's that number 10. This is a problem from the 2008 test. I want to see if you guys can figure out end behavior of this function. First, try it without the calculator. I want to know the end behavior. This is number 18 from the 2008 AP Calculus AB test. Try to answer the question without the calculator first. Talk about it in your groups. So statistically, they said it just wasn't a fair. It was just like they just didn't like. It wasn't fair. Instead of just like moving the numbers. And like, okay, let's just move they just took it completely off the test. But come up with something and then take a look at the graph. Decide on something that function in the numerator and denominator.
Oh, just 2 to the x into 0.
Yeah, well, what kind of 2 to the x in the denominator?
-2.
Yeah, really what that is, again, it's negative 1 times 2 to the x. That's what subtracting 2 to the x is. Again, don't subtract numbers. It'll cause problems. So when the x gets really, really big, this function is modeled by this. And then what happens, Chris? These cancel out. So it's 1 over negative 1. So this this function does have a horizontal asymptote, which is the line y equals -1, or the horizontal asymptote is -1. Do you guys agree with that? I would.
Yeah.
Do you guys agree? Yes? Is everyone fine with that? Well, take a look at the graph now. Because I want to also, end behavior is going both ways. And when they took it out of the test, they wrote a very, very specific note. The teacher's like, remember, it was like, you know, the naggy ant. Remember, when you check end behavior, you need to check positive infinity and negative infinity. I was like, okay. So it may come up, is what I'm saying. If they ask you an end behavior problem, or the limit, something with that, make sure you check in both directions. Take a look at the graph first, and why is it doing that? What's canceling out? No, you guys aren't. If you're already canceling things out, you guys aren't following the end behavior model. When you talk about end behavior, the highest powers take over. So, what are the highest powers in this case? Well, this number, when x is like 100, 2 to the 100 is way bigger than 5. It takes over. You know what I'm saying? So what happens? It flips. So what takes over? Going to the left, 2 to the -20 is 1 over 2 to the 20. That's like, this thing is like 5 plus 0.000000, you know, something, divided by 1 minus 0.00000. You know, 2 to the -20 is 1 over 2 to the 20. Those numbers get flipped. So in this case, the highest powers when you go left is the 5 and the 1. Tricky, eh? Those new tricky AP problem creators. You. So the answer is E. Not, you know, if you were doing this quickly, it's like, boom, this takes over, -1. And you moved on. You know what I'm saying? And so at least you took it off. And they wrote a specific note saying, make sure you check both directions. So what I'm telling you is, if they make a very specific note about it, it's probably going to come up and they're going to test that specifically. Does that make sense, you guys? Interesting problem, okay? Alright, just wanted to go over that one. The rest of the time is yours. The test is tomorrow. Make sure we know that.